Welcome back to the hyperbolic coding chamber. We are back once again. Our room is still a mess. Our life is still a mess, but fortunately, our LeetCode is blessed. So we're back once again, hopefully going to slay more and more problems. I think we've reached it seems to be, I don't want to get too excited, we've reached a good pace with the easies, so I think we should be able to finish them all soon. Granted, we're not learning as much per problem as we used to, but I think the patterns are still useful and they're still there. And it's not, you definitely should follow the do X amount of mediums, X amount of easies, X amount of hard thing, but I don't know, this works for me, so, and I'm having fun with it, so I'm just going to keep doing it. Hopefully it helps me keep building the habit. So from there, we can go on to the mediums, and there'll be no more avoiding it. There are no other problems to do but those problems, and we already got introduced to a lot of interesting methods already just by doing this, which is really interesting. And it does remind me of a situation. I did have an interview once where I had done not a good number, maybe like 30 or 40 mediums, and I was expecting some kind of like tree problem or something like that, and I didn't get a tree problem. I got a simple like array fundamentals string like 2-pointer problem. Because I had done so few of them, the solution just was kind of cheeks, and it doesn't always translate that just because you do something. I guess there's different categories, right? Because I was expecting them to say we need you to program, we need you to reverse this topological sort using SQL or something like that. But it wasn't that. It was so much more simpler, and because I didn't have experience with those problems, it was just like, oof. So that being the case, we're not really doing it for that case. We're just doing it because it seems like a way to naturally slowly ratchet up difficulty. So I'm cool with that, and so far it's been working so far, so it's been pretty useful. That being the case, I think we really might start flying through them, which is kind of exciting. But unfortunately, the mid half of last week to this week, we've been a little bit strapped for time, and that is also the case today. So we kind of have to jump straight into it because we might get cut off at any moment. So I might just have to jump straight into it. But if you're interested in something like this, you should definitely join the hyperbolic coding chamber. Once we solve all the problems, we're going to throw a massive party. Elon's going to be there. Jack Conti's going to be there. Everyone's going to be there. Everyone is here. So if you're in Discord, you're automatically invited. So everyone in Discord is going to be there. I think a couple of presidents might be there, maybe some United Nations officials, but we're still planning out those details. We're in talks. So if that's the case and you'd be interested in something like that, you should definitely join and start doing LeetCode. So that is also the case. Also, shout out to Andy MT. Also, shout out to Pew Pew. They've been helping me out. Pew Pew has given me some pretty good resources. Also, shout out to everyone else who's kind of helped me get here and everyone who answers my questions at Discord, because my brain is dysfunctional. So that's what we're gonna do today. We're pretty much gonna get through these problems and restart the timer, and then see how far we can get before we run out of time. So yeah. So here we have sort by parity. Given an array of integers nums, half of the integers in nums are odd, and the other half are even. Sort the array so that whenever num sub I is odd, I is odd, and whenever num sub I is even, I is even. Return any answer array that satisfies this condition. So, for any array that satisfies this condition, this shouldn't be too bad. We should just have to pretty much store the elements into. Actually, I think you could 2-pointer this for in-place linear time. because there must be multiple answer, and you can return any answer array. But the first one I would go to, we could create an array for odds. We could create an array for evens, and then the output array would just be another array which we create from these two arrays. And so to set up odds and evens, we just say for const num of nums, if num mod 2 equals 0, right, then we'll just say evens dot push num, and then here we can change this to odds, and then we can just say while nums, we'll let I equal 0, and we'll say while odds dot length is not equal 0 and evens dot length is not equal 0. Oh, there's a follow, so could you solve it in place? And then so they're saying the order should be if number sub I is odd, I is odd. So here's the question would be, is 0 okay? So 0 is considered even, and even number does start in the output, so we could probably say that that's okay. So say if I mod 2 equals 0. Actually, we can change that for our output. If I mod 2 equals 0, right, then we want to say output dot push, right, if odds dot evens dot length is not equal 0, we'll do evens dot pop, right? Otherwise we'll do odds dot pop. And then we can copy this I think we should have thought this one through a bit more. Okay, it looks like it runs forever. Oh no, it doesn't run forever. I don't know why it took so long. So the follow-up is, could you solve it in place? So this is not in place. We're using linear space, linear time. So if we have an array, right, that looks like the starting array here, right, and this is actually the correct answer. No, it's the incorrect answer. Right, the first index has to be even for it to be correct. So if we start at I, we could do a two-pointer approach, and then if we find an even, for example, the same thing, I starting at 0, it must be even. Now we're going to check if num sub I is even. If it's not even, then we're going to do some work. So we have to find the next odd number and swap their values. So just to make it simple, you can create a swap function which would take an array of numbers, and it'll take an I index and a J index, and it won't return anything. It's going to save num sub I and then since it saves num sub I, it's going to set num sub I to num sub j, and then it's going to set num sub j equal to temp. And then I think what we're going to do is the same thing we kind of had going before. We'll let I equal 0, and then what we're going to do is say while we haven't made it to the end, right? While I is less than nums.length. I guess you could just do for let I equals 0. I is less than and then we'll say if I mod 2 if I mod 2 does not equal num sub I mod 2, right, then it means we have to fix it. Right, to know what we're searching for, I guess we need to search for I mod 2. Or, I don't know what you'd classify even or odd as, but we'll just say odd or even. I current, right, and what we need will be I mod 2. Right, and we're gonna say now we just want to find the next index j, right, starting at I plus 1 while j is less than nums.length. That j then we'll call swap with nums I j. Why is it so much slower? I mean, it shouldn't be n squared time because we're only checking past I. Wait a second. Wait a second. Couldn't you just sort the array? Half of the numbers. Let me see if we can count. So if we had 1, 5, 2, 5, 8. Next number has to be odd. It has to be 9, or it could be 7. If you sorted this array, it wouldn't be correct. But the algorithm would be simpler, but maybe it wouldn't be faster because you do n log n. N log n is actually better than n squared, I think. Then you just have to swap Maybe that wouldn't even be in place. Doesn't quicksort take log event space? But I would say this, our version is in place, but it's kind of slow. Oh, that's really clever. Why didn't I think of that? Wait, why didn't I think of that? Wait, why didn't I think of that? Place I, iterate through the array. If x mod 2 equals 0, placing them backwards. So if you had 4, 2, you had 4, 2, 5, 8, or 4, 5, 8, 2, and sub 0, x mod 2 would give you 0, right? So you should place and sub, should put x at, oh, that's why you need new space for this one, right? Because that's okay. That was not in place. This would be linear space. That is really interesting. Okay, well, we had the same output. That's a really interesting problem. I think we did first letter to appear twice already. So a perfect number is a positive integer that is equal to the sum. A perfect number is a positive integer that is equal to the sum of its positive divisors. Can't think of any numbers like that. Give an integer n, return true if n is a perfect number. So here we have 28. All the divisors of 28 are 1, 2, 4, 7, and 14. Couldn't you just go from num mod I equals 0, sum plus equals I, and then we'll say num minus equal actually no, it's just a divisor, so you don't need to subtract anything. So they start from 0. Mod 2 is equal to mod 0 is equal to 0. Then 28 divided by mod 1 is 0. So we do sum plus equals 1. 2 works. 3 doesn't. 4 works. Maybe the number goes 10 to the 8. Oof. I guess for sufficiently large number. Maybe we need a complexity that's better than linear time. Oh, I guess they'll let us through. I guess do num over 2. That might make it a little faster. I'll say it is less than or equal to. Okay, it takes, we are able to have the time it takes. I'm sure there's a better way to do this. There's probably a better way to figure out the divisors of a number. Well, I don't know. Bro, no one's going to be using the Euclid-Euler theorem. This is crazy. Yeah, this is some craziness. Design a hash. We'll skip this one for now. Sort even and odd indices independently. You are given a zero-index integer array nums. Rearrange the values of nums according to the following rules. Sort the values at odd indices of nums in increasing order. In non-increasing order. So descending. So you want to sort the odd values in descending order, basically. Before this step, it becomes after the values at odd indices 1 and 3 are sorted in increasing order. Sort the values at even indices of nums in non-increasing order. This is the same as the sort parity problem, except same as a sort parity problem, except we have one more property to sort by. So what I'm thinking is we could load all the even elements into one array, the odd elements into another array, sort them differently, and then do the same thing we did before. And then we'll sort this one in. Oh, do they also want this in non-increasing order, a non-decreasing order? Non-decreasing order. And we'll say for let I is equal to 0. I is less than nums dot length. Say if I mod 2 equals 0, we'll do output dot push evens dot pop, or I guess evens dot length does not equal 0, then we'll do evens dot pop, otherwise we'll do odds dot pop, and then we'll do the same thing here. And let's see if this works. So our output was 4, 1, 2, 3. They wanted 2, 3. Wait, maybe I don't understand this problem. If nums is equal to 4, 1, 2, 3 before this step, it becomes sort the values at odd indices in non-increasing order, so decreasing order, 3 and 1. Oh, so I'm alternating odd and even, and what should actually be happening is Wait, I don't understand. All the values at the even indices should be sorted in increasing order. So the even indices would be 0, 1, and 2. So 4 and 2. You could have 2 and 4. I see. So that has less to do with the actual value of the number. And more if the indice of the number is odd or even. I see. That one kind of threw me for a loop for a second because it was so similar to the last one, but we'll stop there for now.